Hello friends, welcome to 𝐘𝐥𝐬𝐬 classes. My name is Professor Vivek Singh Rathore and I am Assistant Professor in Electronics and Telecommunication Department in Government Engineering College, Bilaspur, Chhattisgarh. I am working there as an Assistant Professor as a 𝐘𝐥𝐬 faculty, and we are here in 𝐘𝐥𝐬𝐬 classes, an initiative by 𝐘𝐥𝐬 faculties for empowering the youth of the nation and so that they can succeed in GATE examination that will be happen in the upcoming year. So in this video lecture series I am taking signals and system, which is a very important subject for GATE examination for electronics and telecommunication, and in this I have completed almost 11th lecture, and this is the 12th lecture. Last lecture I have completed the classification of systems, and in that we have completed time variant and time invariant system, and in this lecture we will see another classification, that is causal and non-causal system. So what are these type of system, and how we can judge by seeing the expression that it is a causal or non-causal system. We will see that. So let's get started and we will see our today's topic, that is causal and non-causal system. Okay, fine. Causal and non-causal system. So what is it? Causal. You must have remembered causal signal and non-causal signal. The signal which exists after t is equal to 0, that signals are called as causal signal, है ना? And the signal which exists before t is equal to 0 also, that signals are called as non-causal signal, that we have studied earlier. Causal and non-causal systems are those systems. See, we are giving an input to a system. Okay, we are giving an input to a system and we are getting some output. Let's suppose xt is the input and yt is the output. Okay, now see, uh, this is the response. This is the response of the system for input xt. If this response, okay, if this response depends on only input, or we can say as present and past input, then it is called as causal system. Simple definition. What is the definition? See, yt is a response of a system for input xt. If if the response of a system depends upon only the present value of input and only past value of input, then it is said to be as a causal system. And in second step, yt, if the response depends upon present or past or future value of input, future value of present value or past value of input, then it is said to be non-causal system. Simple definition. It is not too much lengthy or not that much that we cannot remember it. So overall you need to see only this value. This is the thing which you need to consider, that if it is the system is depending upon future value of input, it is a non-causal system, otherwise it is input, otherwise both are almost same. So see, let's see some of the example, or first I'll tell you some other names also. See, causal systems, causal system, and there is non-causal system. These are also called with some other name, that is, see, non-causal systems are those systems which depends upon future value of input also, so it can anticipate the value. Okay, so it is called as anticipatory signal system, and this is called as non-anticipatory system. This system is called as non-anticipatory system. So if you have been asked like this, then also you can understand what questioner want to ask something. So see, non-causal systems are generally not physically realizable because it depends upon the future value of input. Actually, input is existing now. Input has been existed earlier, but we don't know input what will it will be after some time, na future. But it is depending upon future value of input. That is why these systems, non-causal systems, do not physically or exist or can be realizable, cannot be realizable. But for some certain things recorded input, if you take recorded input, there you can go forward. Like, see, if you are playing a CD player in a CD player, some things are recorded, you can move forward. There's option of moving forward. But if match is going on live, you cannot move forward, because there you can see your present value, present input is there, live match. And if you are you can see past also, which has been occurred, but there you cannot do forward. But if recorded match is there, then you can do forward also. That is the thing I am telling you. Non-causal systems will be in that sense only, where recorded input is fed to the input, fed to a system. There it can be used as non-causal system. But generally it is not physically realizable. Okay, we cannot physically realize it. So see, mathematically, if you say yt, if it is a function of xt, okay, or xt minus t naught, then it is a causal system. And if yt is a function of xt or xt minus t naught or xt plus t naught, this term is very important for judging it is a causal or non-causal. Then system is non-causal, simple. Okay, now we'll take some questions and we'll see how it works. So we'll take some questions like see, yt is equal to uh, x of minus t. Earlier we have seen this type of questions. We have seen this type of question as linearity. We have seen this question as time variant. Now we'll see it is a causal or non-causal system. So we'll see what we need to check is, let's check at t is equal to some values, negative value, zero value, positive value, some values we'll see. So we'll see some negative value, y minus 1 will take. So it will take minus 1, it will give at so see, at t is equal to minus 1, output is depending upon input future value. Actually, if you see in time axis, you will see minus 1 is here and plus 1 is here. So ultimately it's seeing it is dependent upon future value. So I told you, whenever your signal, if it is not seen like that xt plus c naught, but it is looking like this, you should understood that this is dependent upon future value. And wherever it is dependent upon future value, this signal is this system is called as non-causal system. Okay, so now we'll see some more examples and we'll see how it is working on other type of systems also. So we'll see some example like yt, if it is given question log of x t minus 2, this value is given. So see, in the expression only you can see it is dependent upon only the past value, whatever the value may be, it is dependent upon past value. Then it is called as causal system. And same, if it is question is there, if it is given t plus 2, then you can understand that it is dependent upon the input future value. Okay, t plus 2 is there, so it is dependent upon future value. So it will be non-causal system. You can check from by keeping the value t is equal to one time negative, one time positive, one time negative, one time 0, one time positive. These three value, by keeping this three value, if you put at t, you will get to know the signal is causal or non-causal. Okay, so let's see some more example. One more example I'll take. This system is there. Let's suppose yt is there, and this is x of 80. This system is there. Now what we can first see, first we need before checking t, first we need to see what is a actually. A, because does a value affect the causal and non-causal system, we need to check it. Okay, so let's see. Let a is less than 1, one case a is equal to 1, and one case a is greater than 1. We are seeing that does this value affect our system or causal or non-causal. So for a is greater less than 1, we will say a is equal to half. Let's suppose a is equal to 1, and we will take a is equal to 2. Three values will take. Okay, so here yt will be equal to x of t by 2. Here yt will be equal to x of t. Okay, and here yt will be equal to x of 2t. This values are there. Okay, now see, we'll check for t is equal to negative, what it will come. Yt is equal to t is negative means t is equal to, I think we'll take let's suppose we'll take I think minus 2 value. Okay, t is equal to minus 2. What will happen at c y of minus 2, the value will come x of minus 2 by 2 minus 1. Okay, so see, the if you say time axis, where is minus 2, here is minus 2, and where is minus 1, here is minus 1. Does this value depend upon future value? Yes, it depends. So this system cannot be causal, this system will be non-causal. Now we'll check for t is equal to a is equal to 1. So here we will see, we will take y minus 2, we will take x of minus 2 only. Whatever it will be, y of 0 it will be x of 0, y of 2 will be x of 2. So always it will be dependent on present value only. So this system will be equal, will be always will be causal system only. This will be always causal system. Now we'll check for this value. This is y of minus 2 will be x of minus of 4. Okay, so if you say graph is there minus 2, there is minus 4 here. Okay, no problem. For y is equal to 0, we'll get x of 0 only. Okay, so no problem, it is input only, it is dependent upon input. So y of plus 2 will take, y of plus 2 will get x of 4. Okay, so ultimately see, if you plot it, y of 2 will be here, and x of 4 will be here, I think, है ना? So y of plus 2 is dependent upon x of plus 4. So ultimately somewhere it is dependent upon, if y2 is here and it is dependent upon input of x of 4, so ultimately it is dependent upon future value, and it is also it will be called as non-causal system. So see, the value of a is less than 1 or greater than 1, both condition we have seen, it is a non-causal system. But if a is equal to 1, then it is definitely a causal system. So in many questions we can see this type of thing, like see, we'll try one more question. Yt is equal to x of sine t. Okay, x of sine t is there. Now we'll check how we can check. We'll see all values t is equal to 0, one time negative, and one time positive values we'll see. Okay, so let's see, at t is equal to 0, what happens. Y of 0 will be equal to x into sine of 0, and sine 0 is 0, so y0 will be dependent upon present value, so no problem is there. Okay, no problem is there, I think. Okay, and for t is equal to negative value, negative, let's suppose t is minus pi, so we'll take y of minus pi, so we'll take x of sine of minus pi. So first of all it will be minus sine pi, and sine pi will be 0, 1, and see, sine curve is like this na, and so 0, pi by 2, and pi, so value is 0 only. So see, it is dependent upon future value. Where it is, if it is minus pi, then it is dependent upon future value. So from here you can say that this is dependent upon future value, and so it is not a causal system, it is a non-causal system. Okay, and see, okay, now we'll see some more question, and we'll see, because many questions we have seen in linear also and non-linear also, so that you can be confident in solving this type of question. So we'll see, let's suppose yt is equal to 2xt plus 5. This type of question we have seen earlier, and you must remember that this type of system we have seen, this type is non-linear, but because some expressions are moreover, this expression is time, if you say time invariant system, because there is no operation on time t, and this is causal or non-causal. We can see t is equal to 0, we'll see y of 0, so we'll get 2 of x of 0 and plus 5, and okay, same value. If you will take negative also same, and positive also same. So this type of signal is definitely, by seeing the expression only, we can say that it is a causal system. Okay, now I think next question will take next question. Next question will take see, what will take time, causal, and will take some value. Acha, okay, yt is equal to x of t square. Now we have to see this question, x of t square. Now let's suppose at t is equal to 0, y of 0 will be x of 0. Okay, this is heading towards causal, no problem. T is equal to minus negative, so we'll take as t is equal to minus 2. So y of minus 2 is equal to x of minus 2, minus 2 square is 4. You can see that y of minus 2 is dependent upon x of 4. So ultimately it is dependent upon future value. So wherever future values are dependent upon, there the system will be always non-causal in nature. No problem, we have always calculated. Now one more question will take of we'll see one more question, we'll see it, like yt is equal to t into xt, this type of question. Okay, now this type of question, earlier you must have remembered, is it a linear or non-linear? So you'll say linear because there is no other expression. You'll say time variant or time invariant, there is some multiply of time period, so it should be time variant signal. Okay, there should be time variant signal. It is causal or non-causal, let's check. T is equal to 0, so y t is equal to 0, so 0 into x of 0, so it will be 0 only. So ultimately the values are not an issue. For t is equal to minus 1 negative, what will get, y of minus 1 will get minus 1 x of minus 1. Okay, so see, ultimately why the output, whatever the amplitude will be there, the output is dependent upon the input signal. Okay, the same, it is not dependent upon the future value, it is dependent on the present value only. So wherever, so this type of signal is directly proportional to your input and not the future value. So this type of system can be blindly told as our causal system. Okay, this is termed as causal system. So see, now you can understand that causal or non-causal is not a very big problem. If it is depending upon the future value, it is non-causal system, otherwise it is a causal system. So I hope you are comfortable in causal and non-causal system, how to judge it and how to solve it. So in exam you must be comfortable. So for this lecture, this much only. We'll meet in next lecture and we'll discuss some more type of system, like static and dynamic system, what are stable and unstable system, and what are invertible and non-invertible system. So till then, tata, bye bye, see you, have a good day, keep following us and keep supporting us. Okay, Jai Hind.